Yeah, good morning, everybody. Thank you for coming and thank you for inviting me here to speak as well. So today's topic, I'm going to talk about Kubernetes and how to do auto scaling and load balancing in Kubernetes. So I'm wondering, how many of you know what Kubernetes is? Oh, okay, that's good. So yeah, what was the purpose of the talk? So I think as we see a lot of IT companies, even network operators, right, today, so they need to run all kinds of workloads, like we heard about NetOps, CI/CD, and increasingly, a lot of these workloads are run in the cloud, and they are run on top of something called Kubernetes. Sometimes we call it the cloud operating system. So Kubernetes has a lot of advantages, and some of it which you can use. So today I wanted to let you know of two advantages which you can take off. That is basically auto scaling and load balancing in Kubernetes. But before we talk about what is Kubernetes, before we talk about that, let's talk about what is Kubernetes. So this is the intro. So we have talk about Kubernetes first. Slightly thereafter, we talk about auto scaling and load balancing and some use cases. So first of all, Kubernetes is actually what we call a container orchestration system. So it helps control the life cycle of the containers. You might ask, what are containers basically? So containers are a way to run your application such that it can share the underlying kernel, the underlying operating system. So previously you had a bare metal, and maybe 10 years ago, there was this wave of virtualization where you had a hypervisor on the right here. But each what we call virtual machine needs you to install an OS. So this is usually quite heavy, and it's also take very long time to start up. So maybe about a few years ago, we had this concept called containerized application, where they share the host operating system. So the application itself is very lightweight. It can be started very quickly, and you can pack more of it within one hardware. So it becomes much more efficient. You can make use of the hardware much more densely. So that is what we call containers. And to manage the lifecycle of these containers, we have a system called Kubernetes. So Kubernetes is an open source system, I think originally developed by Google. So what Kubernetes actually means is driver. So it's a helmsman in Greek. So basically it's a controller for containers. So a Kubernetes system is made up of a few components. So we have what we call control plane, where you see on the left, the Kubernetes master, and we have the data plane where your apps will run, which is on the worker nodes. So various cloud providers like Akamai will provide you a managed Kubernetes offering. So basically, the master nodes will be controlled by Akamai, and you just need to deploy your application on the worker nodes. So worker nodes are made up of virtual machines. The Kubernetes master has some processes for you to interact with. So the main thing is, one of the main thing is the API server. So this is how you control the Kubernetes cluster itself through a command line or through APIs. And there are various other things as well, like controller manager to control the lifecycle, scheduler to schedule new pods, and what we call etcd, which is a sort of database. The worker nodes itself is a virtual machines, and there's two default processes called kubelet and kubeproxy to manage the network interface. So your applications, which the containers will run in pods under this Docker framework in worker nodes. So worker nodes are your virtual machines on the cloud. So in a short, this is architecture of how Kubernetes works. So now I wanted to go through how can you take advantage of auto scaling in Kubernetes. So for example, if you have a workload today, maybe a website or operational thing, and suddenly you get a lot of demand. So your workload runs on a pod today, and if suddenly you get a lot of demand on it, it might fail, right? Because it cannot service this demand. So in Kubernetes, you can set up something called horizontal pod autoscaler in order to replicate the pods such that you can scale up to meet demand automatically. So this is by default in the Kubernetes system itself. So basically, let's say you got suddenly you have 10,000 requests, but your pod can only serve 1,000 requests. So this construct in Kubernetes called horizontal pod autoscaler enables you to scale your pods horizontally. Why is it called horizontally? Because it adds pods, not CPUs. Yeah. But before we enable this, we need to install something called metrics server. Metrics server will enable Kubernetes to know your CPU utilization and your memory utilization in the pods. So usually, people want to scale the number of pods based upon how much CPU or memory they have been using in the pods. So when you install this metrics server in Kubernetes, you can do something like top pods, and you can see the number of CPUs and also the amount of CPUs being used and the amount of memory that's being used. So once you install that, then you can install this horizontal pod autoscaler. And here we see that we set the CPU percent as 10. That means if the pod goes above a percentage of 10%, it will automatically spin up new pods until the CPU drops below 10%. And you see the minimum and maximum here. The minimum is the minimum number of pods, and maximum is the maximum number of pods that the pod autoscaler would start the pod. So it will start up to a maximum of 10 pods. So this is what we call horizontal pod autoscaler. It enables you to cater for an elastic demand of load. But we need another autoscaler on top. So what happens if, let's say, the horizontal pod autoscaler, it scales up a lot of pods, but there are no more nodes for it to run pods on. So nodes, remember, are the virtual machines, the worker nodes, which Kubernetes will run on, and the pods will run in the nodes. But what happens if there's not enough nodes? Let's say you start a Kubernetes cluster with 3 nodes, and your pods increases, and there are not enough space for, let's say, 10 pods within 3 nodes. So that brings us to another type of autoscaler, what we call node autoscaler or cluster autoscaler. So node or cluster autoscaler basically is provided by the cloud provider itself. So in Akamai, let's say Akamai Cloud Computing Services, we have the node cluster, and we have a menu for you to enable node autoscaling. So here's the part of the menu. You can click on this menu, and then you can click yes if you want to autoscale the pod, the nodes, and you can set how many nodes you want as a minimum and how many nodes you want as a maximum. So when the scheduler finds that it needs to scale the pods, but it cannot find an empty space in the node itself, it will automatically boot up another VM, run the Kubernetes worker nodes, a new empty worker nodes, such that it can schedule a new pod to be run on it. So with both node autoscaler and horizontal pod autoscaler, you can actually scale up to take advantage of Kubernetes default service for you to cater to a large elastic source of demand. And when the demand goes away, it will automatically scale in again. So you will save costs. So you don't need to provision, let's say you expect maybe a huge demand coming in, but for a short period of time, you don't need to provision a lot in advance. So this will do it automatically for you, and then it will scale in, and then you can save your cloud costs as well. So that was for auto scaling, but I think a lot of people might ask, right? In Kubernetes, you have these pods, and these pods are what we call ephemeral, right? And each has its own IP address, and these are an internal IP. So these pods, they are started up. If they die, Kubernetes will start a new one up, and the IP changes all the time as the pods are destroyed, as the pods are created. So how does a user who wants to use your application know how to get to these pods, and how does it balance the load within it? So this is also provided by Kubernetes. And Kubernetes, so yeah, if the IP dies, then the pod goes away and you start a new pod, you get a new IP. So Kubernetes has this construct called Kubernetes service. So it's just a logical representation of all your deployment of your workloads, which can run across many pods. So Kubernetes service, this logical construct, provides 3 things. One is a stable IP address. So you can communicate with your workload through this one single IP address. It can also provide a DNS name internal to the cluster. So you can refer to it by DNS name. And importantly, it provides the load balancing. So let's say you have 3, 4, 5, 6 pods, you must balance the load equally between all the pods when you got your demand. So there are 3 types of this logical construct for Kubernetes service. The first type is called cluster IP. So this is the default type. If you don't specify anything, you will start up a cluster IP service type. What is the cluster IP service type? So a cluster IP will provide you a single internal IP that you can reference to go to your workloads, basically. This is an internal IP. It's only internal to the cluster, and it cannot be accessed outside the cluster. But this is fine because a lot of times people, when they write applications today, they write it in a microservice architecture. There's a lot of little workloads that need to communicate with each other within the Kubernetes cluster itself. So cluster IP is used quite a lot, where one microservice within the cluster will communicate with another microservice in the cluster using their cluster IP. And how do they load balance between the pods? We'll see in a while. The next type of Kubernetes service is called node pod. Why is it called node pod? Because this exposes a pod on the node. Remember, the node is the VM that you can access that workload. So if there's some way for you to access, for you to get traffic to a node through the node IP itself, then you would expose this as a node pod. What it doesn't do, it doesn't balance the traffic between the nodes. So this is an example where maybe some users can get to the nodes, and through the nodes, they can get to the service to the pods. So this is, imagine this is built on top of the cluster IP. And the last one is load balancer. So load balancer basically builds on top of the node pod. You will balance between the various nodes and then get to the pods. So for a managed Kubernetes service like Akamai provides, the cloud service provider will spin up an external load balancer with an external IP, a public IP, such that you can access your pods. And this is the Linux Cloud Controller Manager GitHub of their implementation of the load balancer, of the node balancer. So now we get to the question of how do they load balance within pods. So when a new pod is created, this kube proxy service within the worker node will always be monitoring it. And when you find it has a new pod created within the nodes, you will update the IP tables. So basically, kube proxy uses IP tables for load balancing. And you can see here the IP tables of a specific node. So basically, it uses some sort of random probability statistic. So let's say this has 3 pods. So 1/3 of the time, it will be balanced to the first pod. The other third of the time, it will be second pod. And then the next third will be to the third pod. It shows 0.5 because that is 0.5 of 2/3, which is also 1/3. So IP tables with statistic method with probabilities is used for the internal load balancing. But to balance within the nodes is usually done by a round robin sort of manner with the load balancer. So there's 2 load balancing here, one between the nodes, and within the nodes is between the pods. So this is how you do load balancing between the pods. So that was it. So some of the use cases which people use Kubernetes now. So first of all, yeah, I showed you this because by using Kubernetes resource, one can harness the power of Kubernetes for both scalability, self-healing. So enable network operators to serve millions of customers at a very high level of availability while minimizing your cost because you can scale it. And we have a lot of examples where network operators uses Kubernetes today, right? So any IT workloads. And today I see even like say 5G core functions like user plane functions and that sort of thing are also being run on Kubernetes today. So this talk is just to inform you on that. So thank you for that.
Thank you, Mr. Yin, for the topic. And the next topic is RouteViews.
The next topic is RouteViews and BGP data. As mechanic, we have Greg Shepherd from NSRC. He is also a distinguished engineer from NSRC. So please welcome Mr. Greg Shepherd again.
Afternoon. Wait, no, morning. Good morning. I'm Greg Shepard. Thank you all for letting me show up today. I am now currently with the NSRC. I actually began at the U of O back in late 90s when RouteViews was a single box. And after spending some time in industry, back closer. Okay, I got it. Better? I see some nods. Excellent. I'm genetically pre-caffeinated, so I can talk really fast. I'll try to go slow and clear, but I don't have a lot of time here as well. So anyway, I bounced around in industry. Steve asked me to come back to the NSRC and give a hand with RouteViews because NSRC has adopted it now. So I'm happy to be part of the team, happy to be part of that project, and I'm very happy to be here to give you some background and history of RouteViews itself. So RouteViews is a route collector. It is the first route collector, and it was originally built as a debugging tool for all of us, the operators. This was a way for you to take a look with a global view of your advertisements work, because without it, you turn up your BGP peering and you have to trace route around to see what the connectivity was. And that's really not an efficient way or even a valid way to see what the visibility is. So with RouteViews at the U of O in 95, we brought up to 7200, a donation from Cisco. Since then, since 97 forward, we've been archiving this data as well. It's not just a live access, but all of the data since 97, 50 terabytes and more is now archived there at the U of O, and Google provides a backup for us also. It was originally part of the network center at the U of O, and now RouteViews has come under the NSRC, which is, I think, is a perfect fit. The NSRC has been what I call the Internet Peace Corps. We've been teaching technology around the world, providing connectivity services, and in this case now with RouteViews as a free service, nonprofit organization, we're providing this global view of the route table for the community at large. And it's housed now at the U of O. It's always been there. U of O has been around for a while, research institution since 1876. And despite my white hair, this predates me as well. So why RouteViews? Originally, again, in 95, it was a debugging tool for operators. We didn't think of this as being really a research tool. But once that page was turned, archiving the data became very important. But as a debugging tool, reachability, check your peer visibility, you can check withdrawals and damping. There's a lot of things you can do by seeing what the global view is of your feeds. Now this 26-year data set is archived. And if you go to this link, you'll see there's over 1,000 research papers now have been published using the RouteViews data. I just have a couple of quotes here from people in the industry you may be aware of. Houston wrote the BGP in 2022 route table. And I think you have a copy of this presentation, but I'll just bring out the quote. This vast collection of data is a valuable research data source in its own right. And that's what's kind of has happened now is the research community is getting all the publishing out there. We see the value as a research tool, but the truth is it is an operator tool for all of us. Here's Aftab Siddiqui. Same idea. We require raw data, raw BGP data, which is made available by two sources, RipeRiz and RouteViews. So RipeRiz does a similar project for their regional members. RouteViews is a global footprint. Now, all this is on our website, but I'm going to bring up some interesting pages here that you might find valuable. This is getting shifted. Can we somehow send it? Is this me? It is me. There, that better? All right, sorry about that. So UFO Infographics Lab took our data set and provided this really fascinating website here, which is actually dynamic. Now, RouteViews is a skeleton crew. We're nonprofit. And some of this stuff you'll see is a little outdated. We do our best to keep up, constantly tail dropping tasks as we go along. So I'll point out that we do have actually, I think 40 plus collectors a day, though this page is 39. But what you see here is live. This is all accessible. You can click on any link and it will burrow into some data, and I'll show you that in a bit. And down below, we can select by type. We did a lot of Quagga deployment some time ago. We're rolling over now FRR. It's our primary deployment in our virtual collectors. And then you see the collectors by region as well. The link is down below, follow and fund. Now we have two types of collectors. Getting a physical router into a location, even in a single RU, is a challenge. We've got a piece of equipment to ship. We've got customs to deal with. We need remote hands, rack and port. And so it is definitely a least preferred option. More frequently today, we see a virtual host, which has been great, but we still need to find a host, prefer the exchange to be the host. and we need rack and port, we need exchange port, and we need transit provider upstream as well. Being virtual, it's much faster to get deployed, much easier to upgrade, and is our preferred method today. Now, from a hardware perspective, this is commodity. We don't write software. We use the open source community completely. So, a large 16-core box stuffed with RAM, a terabyte of storage, and only 10 gig. We are not sending data. We grab all your routes just to collect the routes, but we don't use them to forward. We need an upstream provider to do that for us. So we'll get an X-top upstream, and then our 10 gigs enough just for the archive data to go back to our location. On the software side, again, all open source, Linux-based. We did a lot of Quagga. It's primarily FRR today. I think we did have some Go BGPD at one point. It's a little less. And you can see we're actually using BMP now. Original rollout was with OpenBMP, but that development community seems to really wane. And so we're moving towards Go BMP simply because it's an active development community and it keeps us fresh and on top of issues like bugs primarily, security issues as well, of course. Our collectors are really in two forms. Initially, this was a single box at the U of O. So all the peering was multi-hop and it worked just fine. The trouble is those routing anomalies you're looking for are going to affect those peering. So, gee, I've lost connectivity. What's the problem? I can't get to RouteViews to look at it because it's behind that route problem I'm trying to debug. So having them hosted at the exchanges gives us a better footprint, clearly, helps us scale because we're not going to have hundreds of peers on a given box, but it also gives that regional visibility, geographic diversity, peering diversity, and of course, lets us scale this much better. The cons is this is more infrastructure. We can scale the architecture, but we can't scale our team. We're a handful of engineers. It's really a skeleton crew. And we rely on you guys to keep this data fresh by keeping your peering live with us. The data itself is archived using MRT, the multi-threaded routing tool. RFC 6396 documents this, and it's a standard for dumping the tables, and we compress it in a binary file format. We provide two different file, snapshots. We do a full RIB archive every 2 hours. And then every 15 minutes, we provide just the updates. And this is kept live. We have the full 20+ years of data archived there at archives.routeviews.org, the link. They're all bzipped. You can get to them with the HTTP, FTP, rsync. And of course, that map tool I showed you is interactive, and I'll give you a little bit of that. We also have been deploying BMP. This means you can actually get live feeds of the route view on a per collector basis. Now, we don't do BMP to our peers. Initially, the limitation was just lack of support in a lot of the vendors at the time. But what we found is that churn from BMP from the peers is a lot of noise. It doesn't really improve the data set. What we want is the live feed from the collector itself. So it's BGP directly, TCP session down to our peers, and then a BMP feed up to our Kafka cluster. So here's digging into the map. I just went to the BKNIX, click on the dot, and this dialog box pops up with the host name, the date of installation, the software that it's running, and the various information about its status and reachability. You go to the route, the actual host name, and click on that. It takes you directly to this HTML directory. So you can see it started in October 2019, and sure enough, the first folder is October 2019, and each folder every month gets archived. You open those up and you'll see them by time slot, the 2 hour and the 15-minute updates. So the MRT file type can be accessed with various tools. I'm not going to go into them in detail, but this is a great list if you got access to the presentation. And they're in various flavors, Python, Perl, and others. Depends on your flavor, what you're comfortable with. But any one of these gives you a tool set to then access the MRT file to parse for the actual event or path, whatever information you're looking for your interest. As the new features I mentioned, BMP, there's actually a BMP stream, and I think an Artemis instance that's running at UC San Diego. I think it's publicly available. I'm not certain, but you can take a look, and I think you can roll your own Artemis as well, at least for now. And if you want a live feed, we do have the Kafka cluster available to you. Now, remember, we're not an infinite resource. And so as more requesters come up, we're probably gonna hit some limit with our Kafka deployment. We're always looking for more resources to expand that. Don't hesitate to ask, and we can show you a way to get onto the Kafka cluster and write your own scripting to it to look for dynamics in the live feed from various collectors. We've also have enabled RPKI validation. This has been incredibly helpful. In fact, I'll show you a little example as I dug in, and Philip and I were yucking about this a bit earlier. This lets you look at the validation state of any given feed, and it's connected to the ROAs, and we're starting to backfill the data as well to keep it up to date at the archive level. So how do you peer with RouteViews? Pretty straightforward. We prefer full tables. We don't always get full tables, and that's okay, whatever you're comfortable giving us. But we don't want your defaults. We don't want your null routes. We don't want your 1918 internal addresses at all. We don't accept add path, and we won't send any routes back to you. Peering session will come up, we'll take everything, but we're not forwarding traffic. This is just a route collector. So we won't give you anything back in the BGP feed. And if you're connecting multi-hop to the UFO, just remember it's eBGP multi-hop. So BGP is the backbone for the global internet architecture. It's the infrastructure that all of us have learned and depend upon. But in order to maintain its stability, we have to be able to monitor it in some way. So RouteViews has given us that. And I don't think everyone necessarily agrees with me. I was there in the mid 90s when this all began. And it was my experience that I don't think the internet would have grown as quickly or as stable as it did without something like RouteViews in place. It was clearly the operators asking for something. UFO was where the ideas were kind of centered. Cisco gave us that router, and immediately as operators, we were able to take a look at what our feeds looked like from other perspective. This collector infrastructure today gives us command line access. These are routers. You can actually get on them and do your show commands if you want to see immediately what's happening with your feeds. This gives us the prefix visibility. You can see what damping and convergence times are taking place, what your stability is, and you can compare these views on a per collector basis. So you get regional views, you can get your local view, and you get a global view of your advertisements into the internet at large. Gives you this troubleshooting reachability, of course, and all this data is available archived. So if some transition took place within your network, you can then go to the archive and find out when this happened, and then hopefully debug what the root cause was. As I mentioned, each one of these are routers. You can tell it to them directly. And we have a naming convention I'll dig into a little bit, but no username is necessary. Show commands are there. This is Telnet, and we put rate limiting on it because this is obvious when someone thinks this is their toy that's personal, it can overwhelm the system and keep other people from accessing it. So we have put rate limiting on it, and we ask you, please don't script to the Telnet. We actually have an API now that's available to you. I don't go into it here, but you go to the website, you can take a look at the API documentation, and you can automate your own scripts then to access this information without overloading our Telnet session. Now, people often ask, why not SSH? Why? We don't have any security issues. We've got nothing to hide. This is just a router, and you have access to show commands and have at it. It's important to note, though, because this is a route collector, the next hop will be incorrect. We have peering across the exchange, but we have another port, this to our transit provider, where we archive the data through that path. So showing next hop is not going to give you information. What we're really doing is archiving paths alone. And the kernel is going to point to this next hop by default. So again, it won't be correct when you're looking at the data set. Now, this is kind of breaking down our naming convention. Remember, this was an idea that took place in Dave's office, the computing center. And from there, it has organically grown through the engineers that have come and gone at the University of Oregon. So initially, we just had a box, and then we had a second box, and the naming kind of expanded from there. Well, once it's gone globally, this naming convention got a little cumbersome. You can see like telnetting to the BKNIX, it's route.views.bknix.routeviews.org. That's our current naming convention. It got a little ugly. Moving forward, we're cleaning this up. So our most recent deployment of a collector was in Malaysia. And the new naming convention then is the name of the exchange, dot the closest airport, then .routeviews.org. So in the Malaysia case, it's DECNIX, JHB, routeviews.org. Now we can't just roll out changes across all the collectors today. There's a lot of scripts written around the old naming convention, but we plan to roll this out slowly and incrementally so we can clean up the naming convention, make it simpler for everyone moving forward. Now, I just hopped on various boxes and didn't do full debugging, but just kind of to bring out some things in the data set that I thought were kind of interesting. Well, first thing I did is I ran to the BK exchange. I took a look and we only see 6 neighbors currently. Now, I would imagine this week in this room, many of you are on the BK exchange. I would encourage you, please participate. So RouteViews is a great tool for the operators, but it's only as valuable as you participate with us. So if you use this and you see the value of this, please come peer with RouteViews. Additionally, if you take a look, we don't see full routes from these peers. We're seeing probably some local routes. I didn't dig into it deeply, but there should be 900,000 plus prefixes being advertised there. We see in at the most 652. And that's okay. We'll take what we get. We prefer full routes. If you want to peer with RouteViews, you can send us email. You can go to our contact form on the web. I prefer you using the form. We're trying to automate this as best as possible. As I mentioned, this was an organic project that grew through National Science Foundation grants and the kindness of people like Google and some others. But we're trying to formalize this process and formalize this architecture so that we can grow this even further. The request is to grow this, like from the research community, several orders of magnitude. And with our current staff, that's probably not going to be possible. If we automate this, we can possibly get there. So some interesting things. I took a look at the prefix for this event today that you're seeing on your Wi-Fi infrastructure. And unfortunately, it's not at the BK exchange. Now, it may be there on some of the peers who are there. We just don't see it in our collectors because we don't have enough peers from the BK NICs to know if it's actually available. So I went to the RouteViews collector at the U of O and took a look. And you can see this /28 is covered by a larger, a shorter prefix /22. And it's got great global connectivity. So thank you to the hosts and those engineers who rolled this out. Same with V6. It's got great connectivity, but unfortunately, like I said, without the peering at the BK exchange, I couldn't confirm what our local reachability was. So going back to the U of O, just to show IP BGP sum, this is one of the originals. It's actually the second, obviously, RouteViews 2. There are 77 peers in this given route. Now, clearly this wouldn't scale from a single box, which is why we've gone to multiple boxes, and another reason why we've gone globally to distribute this architecture. But I want to point out some things that are a little interesting. Well, first of all, we see full tables. There's 900,000 plus paths from many of the peers. Some of them are not up. This is kind of a legacy to how this began. This was handshakes in the hallway at various NOGs like this. An operator who had sympathy for this service needed an access. We got a peering up, but once they left, the network they worked for may have had no record of their relationship with RouteViews. So we see a lot of these hanging peering sessions still live. Now, we're trying to formalize this now. We would like to have a relationship with the exchange at every collector so that if that engineer, that operator who we had the original relationship with moves on, our relationship with the network and with the exchange doesn't go away. And this will happen on a site-by-site basis. I'll just give you an example here when you look at this one that's older than most. Digging deeper, let's see, you see all the communities are preserved. Large communities are also preserved in the archive. And with RPKI turned on, you can see the status, in this case, valid, which is a great tool. Another anomaly, just poking around, here is AS 11432 getting prepended 23 times. I'm not going to propose why they're doing this, but this is exposed out there. I would say majority of the anomalies you see are not malicious. It's just an accident, some ignorance, possibly a quick fix. And you guys know your day-to-day is firefighting quite often. So you fix something, I'll go back and do it better later, and you move on. You never get a chance to go back. Well, now it's publicly available. Everyone sees what you've done, and there's a chance sometimes you get some email and ask you to clean things up. So this was something interesting. I just did an RPKI invalid, and I started going through the files trying to see, which invalid feeds we're getting, and I found something awfully interesting. What we see is a prefix, this 212.193.8/24, this being originated from 2 different ASs. Now that in itself is a little odd. All of them are failing RPKI. They're all invalid. So I dug a little deeper, and the owner of the prefix is in Palestine. All right. The owner of that anomalous AS is actually in Turkey. Now, Philip was banging on this a little bit. We were kind of scratching heads. His BGP foo is superior to mine, and he found this interesting as well. It could be there's the actual multi-home with a private AS that's getting pulled. What we see is that all of them are invalid. And in some cases, like back at the U of O, we're seeing that the transit providers are actually dropping these invalid advertisements. The actual AS of origin is in Palestine. So I can't say exactly what the problem is. It could be a misconfiguration. I don't think it's necessarily a hijack, but all of them are invalid and getting dropped. They probably have very little, if any, connectivity globally, but RouteViews being regionally distributed allowed us a way to take a look at this stuff. And even if you have a misconfiguration like this and you don't have reachability globally, you can go to the local collector and see what's happening and find your misconfiguration and fix things. All right, so in conclusion, the email list, jump on. Great place to just contact RouteViews, ask some questions, receive updates along the way, see where our next exchange is coming in. We're always looking for new locations. And I would suggest if you're going to peer with RouteViews, you can go to the email list, but we have a forum online now. It's not all that robust. We're trying to make it more robust and automated. And so if you use it, we'll support it better. And then we can actually improve the service for everyone. And again, the NSRC is now the host of RouteViews. I think it's a great origin for it. I'm very happy to be part of that team, very proud to be part of that team. Like I said, they dusted me off and asked me to come back, and RouteViews was something that was motivating enough to come to events like this and support a project that I believe in. All right, questions? Did I speak too fast? You heard that part. All right, good. Thank you very much. Actually, feel free to contact us.
Yes.
Philip's here, I'm here. If you want to peer with us, you can contact us. We're going to be here all week.
Okay, thank you very much, Greg. Yep. So for the last speaker, we have Champika from ICANN. Sham will be presenting from remotely. So Sham, over to you, Sham.
Yeah, thank you, Nan. Can you hear me well?
Yes, yes, I do.
All right, let me just try to share my slides as well.
Yeah, I can see. Okay.
Do you see my slides?
Yes, very good.
All right, thank you very much. Sawasdee krap. And first of all, I should thank the ThaiNOG organizers for giving me the opportunity to yeah, sorry about the video. Yeah, first of all, I should thank the ThaiNOG organizers for giving me the opportunity to present remotely. Sorry that I could not make it physically this time. Okay, my presentation is going to be on a tool called KINDNS. We pronounce it as KINDNS. So this is kind of a framework or a tool, mainly to promote the DNS security operational best practices. So that's the objective, and I will go through a few slides, mainly talking about what are the expectations, especially the best current practices in relation to DNS security, and also how you can utilize this tool, the KINDNS, to evaluate your network and basically the DNS ecosystem. All right, let me just go to the next slide. So if you see this diagram, so this is a typical DNS ecosystem. And then you can also see the target points where we can get attacked, especially in DNS. So you can see the stub resolvers. So the stub resolvers are running in our devices, the operating system, and that will communicate with the recursive resolvers, usually run by the recursive resolver operators, like ISVs, the mobile operators, the public DNS service providers, and so on. So there are many recursive server operators. And then these recursive servers, they would talk to the authoritative servers. So you can see, as you all know, DNS is a hierarchical system. So you will see there are authoritative servers along this hierarchy. So you might see the root servers. Root servers are still authoritative servers that keep the root zone. And then the TLDs, second levels, and so on. Now, for graphical purposes, here we only show a single system, but in reality, you can see multiple systems, clusters, and so on. And then also, if you see the databases related to the DNS, the registries, they maintain the registry databases. Registries communicate with registrars using protocols like EPP, for example, Extensible Provisioning Protocol. And then the registrants, they are the ones who go and get the domains from the registrars or even resellers, for example. And then once the registrants, when they get their domains, they do access these databases, they do update these databases through some sort of an interface, like a web interface. You may have been doing this. There are various interfaces like cPanels and so on, where you can update the databases as well. So in this whole system, as you can see, there are many sort of DNS threats that can occur, where you see in all these red sort of crosses. The stub resolvers can get attacked because, and also actually most importantly, this traffic that goes from the stub resolvers to recursive resolvers that goes in clear text in DNS. I mean, that's how the protocol is designed many years ago, like in 1980s. So during that time, that was, if you see the initial RFCs, that's how the protocol is sort of, designed. And then the recursive servers would talk to the authoritative servers. There can be various issues like cache poisoning and things like DNS hijacking and things like that. So if you consider, and similarly again, here, we also have to think about the registrant's perspective, the user credentials, because there nowadays, especially, there are lots of these credential thefts do happen, a lot of phishing attacks, and then the registrants would go to a phishing site, and then their credentials are being stolen, and they, maybe the attacker could log into one of these databases and update the DNS records. So these can create a lot of problems as well. So you can see the bottom line in this whole ecosystem is that there are many points of, there are many attack points, and it is very important for us to consider all these attack points and then try to actually fix those. If there are some points, apply some better security mechanisms and then try to fix those. So that's the sort of objective. So to do that, you need to have some best current practices. So that's what we are going to talk about in this presentation. So in the case of best current practices, again, to protect all those places, there are various ways. There is not only just one mechanism as such. There are many ways. Earlier, I was talking about the traffic that goes in the clear text. So if you want, you can do encryption there. There are protocols for that, things like DOT or DOH. Then talking about the protecting of DNS data, there is a security mechanism called DNSSEC or DNS security extension. DNSSEC is also very important, where you would sign your zones, and then the recursive resolvers would then validate this data that is getting from the authoritative servers. And then again, you have to apply the proper security hygiene in all these systems. Even the earlier I was talking about the providing secure interfaces to the registrants and so on. So there are many mechanisms where we can provide better security. And then if we can apply these security best practices, then we can try to protect the domain name system as a whole. Now, the objective of this presentation, I told you, is it is to talk about a tool or a framework called KINDNS. So now if you expand the term This is what it talks about, knowledge sharing and instantiating norms for DNS and naming security. So this is the one that we say KINDNS in short. So it is pronounced as KINDNS. So from here on, I will always say KINDNS, and that stands for this, this acronym. So what is KINDNS? So this is, as I said, it is an initiative to produce something that can help a wide variety of DNS operators. I mean, these DNS operators can be small or large, medium, it doesn't matter. Sometimes, you could be a small operator who might be operating, maybe a few DNS servers, or you could be a large operator, DNS service provider that provides, large number of clients, and so on. It doesn't matter. That it is always helpful to follow these guidelines and then apply those guidelines in your environment. What we are talking about here. So who are the targeted operators? Now, when you talk about DNS, the domain name system, as I said, it is very hierarchical. On the top of the hierarchy, we have the root, and then we have top level domains. So if you are managing some top level domains, if you're running some authoritative servers, especially if you are an authoritative server operator, you could be managing the authoritative servers for top level domains. And then also, it could be that you could be managing authoritative servers for some critical zones in your country, for example. So you could be one of these type of operators, or you could be running your own second level domains as well. Because if you have a second level domain or even a third level domain, then you could be running authoritative servers as well. So one type of targeted operator category for this tool or for this framework is the authoritative operators. The other one is actually the resolve operators. That's the other category. Now, the resolve operators can be, again, separated into few categories as well. One is called the closed and private resolve operators. So these are like corporates, for example, because, some corporates, for example, like banks or some universities and so on, they run their resolvers only for their users, right? So these ones, we call it as closed and private resolve operators. Then we also have shared private resolve operators. So these are like ISPs, the service providers, mobile operators, and so on. So in this category, they run the resolvers for their clients, their customers. And then the other category is the public resolve operators. So in the case of public resolve operators, they run these resolvers for the public. As we know, there are many public resolvers out there now offering their service to the general public. So you can see there are a few categories within the resolve operators. And then the other focus area is actually this hardening the core system. So this is basically applying the general security hygiene in your network, in your core systems, and so on. So if you can protect, or if you can apply the best practices in all these places, we can try to protect the DNS ecosystem as well. So by joining this KINDNS initiative, the DNS operators, they can voluntarily commit to adhere or identify and adhere these practices, and then become goodwill ambassadors within the community. So what we are talking about is you can use this framework, go through the best practices. First of all, you can evaluate your environment, see what you do now, then evaluate whether you are doing this right or not, and see where you can improve, and then try to apply those best practices in your environment, and then become a goodwill ambassador so that others can learn from you and others can follow you. So that's the objective of this KINDNS initiative. So you may have heard about manners, actually, that ISOC initiated. Manners focuses on the routing security aspects. So this is very similar. KINDNS focuses on the DNS security aspects. So they complement each other, actually. Now, so if you are earlier, I was talking about different categories, right? I was talking about the authoritative DNS server operators, and then the resolve operators, and so on. So if you are a authoritative server operator, then especially operating these TLDs and critical zones, you can follow these guidelines. So that you can follow these guidelines. There are several guidelines, the best practices that you can follow. And so, for example, I wouldn't, due to the time limit, I wouldn't go through everything in detail. But if you pick some of these, like must be DNSSEC signed and follow the key management practices, especially if you're managing a top-level domain, it is very important that you should sign your zone, DNSSEC sign zone, right? So once you sign your zone, then you can make sure that the second levels under yourself, then they can also actually sign and then propagate the trust to yourself. So especially if you are a TLD operator, it is very, very important that you should sign your zone. When I say TLD operator, generic top-level domain operators, they are, they have all signed their zone because they have contracts with ICANN. But if you're talking about country code top-level domain operators like CCTLDs, CCTLDs do not have contracts with ICANN. So that is why we are trying to say that, especially if you're managing some CCTLD zones, it is quite important that you can apply these practices, like DNSSEC especially. Still, in the world, there are close to about 180 or so CCTLDs who has not deployed DNSSEC or signed their zones, the CCTLD zone. So that's why, if you think, you should be doing this, it's very important thing, right? Of course, from .th perspective, THNIC's perspective, THNIC has signed their .th zone many years ago. So especially from Thailand's perspective, there's no problem. The second levels, third levels, you can also sign your zone and then propagate the trust to your parent level. And the other thing is, of course, the key management best practices. These things also has to be followed, especially if you are a TLD. You need to have some better practices, especially managing these DNSSEC keys. And then authoritative servers, the transfers must be limited because you have to make sure that you need to have some proper access controls and things like that. And then the zone file integrity must be controlled. It is very important to monitor that. And also, if you're running some recursive servers and authoritative servers in the same environment, make sure they are running on separate infrastructure. Don't put, all your recursive services and authoritative services in the same name servers. At least have some minimum number of servers, at least 2 servers for a service. That is also important. So these are, kind of, important guidelines, especially if you are running some TLDs. Also, the diversity factor is also something quite important when it comes to the DNS software packages. Because why we are trying to stress on this, if you use the same DNS software across all your name servers, then there is some possibility, in case if there is some vulnerability with a certain DNS software, then you're affecting all your name servers as well. So that's why it's quite important that you have to have some diversity even within your DNS software as well. Make sure that your authoritative servers, they run in diversified infrastructure. Don't put all your name servers into the same network, same subnet, or even same data center, and so on. Try to have some separation. And then also, actually, the infrastructure should be monitored as well. So these kind of guidelines are some good best practices, especially if you're running some top-level domains or TLDs and critical zones. Similarly, for second-level domains, you would follow not all of those, but a little bit less than some of those things, because second-level domains are not critical as top-level domains. But still, some of the key important ones are listed in these guidelines. So basically, the KINDNS tool will go through all these different guidelines. So we will have a, when you try to use this tool, it will have an evaluation based on your environment, and then check against all these different best practices. And then if you are a resolve operator, especially again, we spoke about different type of resolve operators. If you are a closed and private resolve operator, like as I said, if you are a corporate or a bank, university, and so on. So these are some best practices that you can apply in your environment. Now, earlier we were talking about DNS signing if you're running, TLDs or critical zones or second level domains. But in the case of resolve operators, you should be validating the queries, basically DNSSEC validation. That is quite important. So you should enable DNSSEC validation in your resolvers. Then you have to have ACLs, the access controls, right? Because there could be quite a lot of queries coming from unknown host as well. Queue name minimization, also important, because as a resolver, you're sending all these queries to root servers and TLDs and so on. But root servers, TLDs, and so on, they don't really need the full query itself. So you can use queue name minimization to actually, not to send the full query itself. And then again, we spoke about having different infrastructures for authoritative and recursive name servers. That's also important. And then also the having number of servers in diversified infrastructure, and then the monitoring and so on. So these are all important best practices, especially if you're running your recursive servers in a closed and private environment. And then if you go to the next category, that is the public resolve operators. So even here, actually, before that, we also had the shared and private resolve operators. This is ISPs, and then mobile operators. Again, very similar practices. Here, you can also use enable DOH and DOT as well. Remember earlier I was telling about the queries that goes in clear text, right? But if you want to have if you want to provide the encryption to the clients, then you can enable DOH and DOT here. Then for public resolve operators, again, you can see there are a number of other practices as well here. You can apply these in the public resolvers that you are running. So this is the bottom line. I mean, even though I'm not going to go through every of these guideline in detailed way, but the general idea what I want to give you is that this KINDNS tool go through several best practices depending on your category to make sure that you are applying this best practice in your environment. And then the hardening the core, if you remember, like we also had another category to make sure that you apply the best practices in your system, the environment, and so on. This is where even things like whether you are running proper network controls, access controls, and then things like whether you are applying BCP38 or manners type of filtering, and then the DNS servers, how those DNS servers are being placed, then the system configurations, all these user permissions. So these are all the general, and the credential management, all these kind of general security practices should also be applied in your environment as well. So that's the hardening of the core. Now, once you do all these, Actually, even before you are doing all these practices, also initially what you can do is you can do a self-assessment of your environment. So you can go to the KINDNS website, and then I'll show you the details over there in the next couple of slides. So basically, KINDNS would do a self-assessment based on the input that what you provide, whether you are a resolver operator, whether you are authoritative server operator, and so on. So based on the type of input that you provide, the KINDNS would evaluate and provide you some reports. So these reports can be downloaded, and then you can use these reports. These reports are quite detailed reports, how you can apply, what are the things that you can actually apply in your environment, and so on. So, and first of all, of course, KINDNS is a tool that you can participate voluntary, right? So this is a voluntary tool, but it's good to try this out. I mean, you can try this out anonymously. So these self-assessment can be done anonymously. You don't have to actually specify your organization or your name and so on. You can try this out first, right? So how to try this out? Go to www.kindness.org, KINDNS.org, and then you will see these two options. One is to do the self-assessment, right? So self-assessment is basically you're doing an self-assessment about your DNS environment. So whether earlier I was going through different categories, right? Resolver category, authoritative server category, and so on. So it will ask whether, in which category you want to evaluate yourself. And then if you are an authoritative server operator running authoritative servers, then you would actually go in that category, and then basically supply your inputs based on the questionnaire, and then KINDNS will provide you a report or a best practice guidelines what you should be doing in your network. So this is totally an anonymous thing. But if you want to be part of KINDNS and join KINDNS and also become an ambassador, as I said, a goodwill ambassador, so that others can learn from you, others can follow from you, then you can join KINDNS. So when you join KINDNS, then of course, then we will still have some sort of an evaluation with you. So you will get some, ICANN will communicate with you. And then also we will basically go through your environment and see whether, how you're running, what sort of best practices you're applying in your environment and so on. And then if we see that, you are applying all those practices, and if it's all fine, then you will be listed as one of these KINDNS ambassadors, right? So that others can also follow you, others can also learn from you as well. So if you go to KINDNS website and also see the participants, there are lots of actually information here in this website, tools and a lot of guidelines and support and engaging, how you can participate and so on. And also you can see a list of participants who has already joined KINDNS. And then you will also be basically published, listed in the website, and then you can become a goodwill ambassador there. So this is the whole idea of this framework, of this tool. And if you want to have some further discussions on this, you can discuss, you can actually join the KINDNS mailing list as well, where from this, if you send an email to this. But most importantly, you can get all the information from kindness.org. So this is what I wanted to convey in my presentation. So KINDNS is a tool, a framework that focuses on the DNS security operational best practices. And then the whole idea is that try to evaluate your DNS environment. And then what you are doing is whether it is right, whether it is current, is it a best practice? If not, you can try to correct yourself and then apply the best practices in your environment. So that's the objective. And thank you very much for listening. And if you have any questions, I can take now.
Any question from online and from the audience on site? Any questions? If no, thank you very much, Champ, for your kindness, for KINDNS presentation. Thank you very much. Yes,
Thank
so
you
that's
very much.
end of the morning session. So we have the afternoon session, which is